Hi, welcome to this course. Myself Muhammad Yaqub, I am the founder of Scratchland. In this course, we are going to learn a real-time project in computer vision, that is driver drowsiness detection using computer vision. When we learn about a project, we have to understand the problem first. Nowadays in the world, there are a lot of driving accidents are happening day by day. So if we see what is the main root cause for the accident, one of the main major issue is driver drowsy issue. So once the driver feels sleepy or if he slept while driving, no, it should be surely fatal accident. So to solve this problem, we have come up with some fantastic idea called drowsiness detection using computer vision. So in this project, we will be learning a lot of modules like facial detection, facial landmark detection. After that, we will be implementing logic to identify face drowsiness detection, and then we have developed like real-time video processing and then alert generation, and then we have developed Tkinter graphical user interface to make everything easy for development and understanding it. So this course is going to help you in understanding the computer vision in a better way. So
I'm going to give a brief overview of the project. The project is called Driver Distraction Monitoring System, and in this project, we aim to predict various driver distraction activities such as safe driving, drinking, doing hair and makeup, texting on the phone, texting with the left hand, texting with the right hand, and so on. These are the main categories that we'll be predicting in this project. We will then collect a custom dataset from Google and train the model using a deep learning algorithm. Finally, we will perform inference using the trained model on the VS Code platform, and we will develop a Tkinter GUI to display the results in a Tkinter window. This is a brief overview of the project. We have two sets of input videos, input video 1 and input video 2. There is a requirements txt file which contains some important libraries needed to perform inference with the trained model. This is the final inference code and the driver distraction monitoring system IPNB file which is used to train the model on the Google Colab platform. First, we are going to see how to train a machine learning model using the Google Colab platform, which is a free online tool provided by Google for running code in the cloud. To get started, you first need to open your web browser and go to the Google homepage. Once you are there, type the words Google Colab into the search bar and press enter. After that, you will see a link to Google Colab in the search results. Click on it and then you will be welcomed to the Google Colab interface where you can begin working on your project. First, you need to upload your IPNY file here. To do this, simply drag the IPNY file from your computer and drop it into the designated area on this page. Once you have dropped the file here, the upload process will begin. Now the file is being uploaded to your Google Colab notebook. Please wait a moment while the upload completes. After the upload finishes, Google Colab will automatically open the notebook for you. Now the file has been successfully uploaded to the Google Colab notebook. Google Colab is a code development platform and it is open source developed by Google, and the GPU is free for up to 6 hours. After that, it will be disconnected and then it can be reactivated the next day. And we are able to train deep learning algorithms and machine learning algorithms on the Google Colab platform. Most of the Python packages and libraries are pre-installed on the Google Colab notebook, so you just need to import and use them for your purposes. First, I'm going to explain the code for the project and then I'll show how to train the model. First, you need to import Google Drive to store our files in Google Drive and to access files from Google Drive. If we store our files in the Google Colab notebook, then they will be stored in RAM memory. Once the notebook is disconnected, the files will be deleted. This is the main reason for storing files in Google Drive. First, you need to import Drive from Google Colab, then use Drive, mount. Next, after executing this cell, it will be successfully mounted. First, we need to collect a dataset to test our model, and we are going to use a dataset from Kaggle. Kaggle is an open source platform that contains a lot of real-world datasets, and we are going to use the State Farm Driver Distraction Detection dataset, which includes up to 10 classes. Next, import files from Google Colab, which allows you to download and upload files in the Google Colab notebook. This is the Kaggle JSON file. This is the Kaggle API key, which is used to download datasets from the Kaggle website. Then install Kaggle and create a directory for .kaggle. Use cp to copy Kaggle JSON, then check that it is available in the public working directory and then set the permissions for Kaggle JSON. Next, create a new folder inside Google Drive to store the dataset in unzipped format for driver distraction reduction. This is the folder name. First, check whether this folder exists or not. If the folder does not exist, then create a new folder. The next step is, this is the command to download the dataset from Kaggle and then move the dataset zip file into the driver distraction reduction folder you created. Then unzip the dataset using the unzip command. Import the necessary library for data visualization. Emutils is a basic Python library. Next, import paths, which is used to access files from a folder. Then import random, which is used to select random data, and MATLAB lib, which is for dataset visualization. Next, OS is a basic Python library, and below that is a library for image processing and image handling. Then CV2, which is also a library for image processing and image handling. NumPy is used to handle arrays of data. Then TensorFlow, which is a deep learning framework used to build deep learning models, train them, and then make inferences using the trained model. Image to array, which is used to convert images into array format. The next step is dataset visualization. We are going to visualize up to 25 images from the train folder in the state farm driver distraction detection dataset, which contains two sets of data. One is the training set and the other is the validation set. These are the class names. And then there's the Emutils library, which is used to access file paths from a folder. These are class names such as normal driving, texting right, talking on the phone, texting left. And this is the dictionary format. This is the key and this is the value. Display images is a function. You need to call this function with some important arguments. The arguments are image paths, title, column set to 5, and number of images is 25. Then shuffle the images, set the minimum number of images to display, then set the number of rows based on the number of images plus columns minus 1 divided by the number of columns. Then the figure size is set to 12 by 12. This is the width and this is the height. Then set the plot subtitle. Then iterate through the images one by one using a for loop on the enumerate object. Then create a subplot with PLT subplot. Then open the image and convert it into grayscale format. Then get the class names based on the names. Then apply the title with PLT title. Title is reaching behind air and makeup talk into passenger. Set the plot title layout and finally display the image here. When you are going to train deep learning algorithm or deep learning model, after collecting a dataset, you need to pre-process your dataset into deep learning input image size, such as need to resize image into model input size, such as 128, 224, 256 or 512. You can choose any one of the dimension for resize your image. The next dataset normalization, if you want to get better result or do you want to reduce training time of deep learning model, you need to standardize your images under 0 to 1. First, you need to import OS. It is a basic Python library. Then random, matplotlib. Then define a data folder. The folder name is content, images, train. I'm going to take only 500 images for each classes. In validation, I'm going to take 100 images for each classes. Then I define train paths and the validation paths folder here, which is used to get train paths. Then OS path run join, which is used to join your path, check whether the folder is exist or not. Then you can proceed to obtain the images path with a particular file extension, PNG, JPG, JPEG. Then we'll shuffle the images. Subsequently, we will store the images. A training count of 500 images will be carefully stored in the designated training paths, and a validation count of 100 images will be precisely stored in the respective validation paths. This is the final train counts and validation counts. Then we are going to plot using bar plot. The figure size is 10 and 6. This is the width and height of the plot. This is the bar plot. We need to give counts such as train counts and validation counts. This is the values. This is the class names with font size 12 and then number of training images, font size 12, number of training images per classes. Then finally display a train set of images, and this is always for validation. It's similar to training. And finally display image using PAT show. Then simple dataset loader, which is used to load a dataset such as image read. Then apply pre-processing technique. Then finally it will be stored list. Then finally it will be written output as NumPy array format. This is a class constructor which is used to access pre-processing technique inside the load function. There are two set of pre-processing adder in this project. One is simple pre-processing, another one is image to array pre-processing. These two techniques, they're in list data type format. Check if there are any preprocessor techniques available in the list. If it is none, then return empty preprocessor. Then load, it is a function which is used to load datasets images. In this function, we need to give image paths and verbose, which is used to display your progressing, which is used to store train images and validation images, then which is used to store labels such as driving, drinking, hair and makeup. Then iterate images using for loop and enumerate object. Then read image using OpenCV library, which is CV2. Then pixel will be stored image variable, then access labels name. Check self preprocess is not none, which means it should not be empty. The pre-processing technique must be there. List. Then apply pre-processing technique to store pixels. Then apply image to array preprocessor under simple preprocessor, which is used to resize. Then convert into NumPy array format. Then finally append pre-processed image to data on the labels. Verbose switches to process a image and display a image count. Then finally return into NumPy array format such as data on the labels. This is a simple preprocessor class which contains constructor under preprocessing function. In this constructor, which is used to access a variable inside this function, we need to give with it, which is used to resize the entire area, which denotes resizing. Then resize using CV2 library. Need to give image path self, width and the self height. Interpolation is self inter. Then image will be resized into the given size. Then apply image to preprocessor, which is used to convert image to array format. Then create a new object for simple preprocessor and image to array preprocessing classes. Object name is S, P and the AP. In this simple preprocessor, need to give image, width and height. This is a list of comprehension which is used to access train paths. Then all the train paths will be stored. All train paths variable which is similar to validation paths. Then print here all train paths count, all validation paths count. Then initialization of simple dataset loader class. Then create the object for this class. The class name is stl. Then call here load function using stl object. Need to give all train paths where both is 1000, which it loads 1000 images per whereabouts, which is similar to validation data. Simple dataset loader, they need to give all val paths. Then use the data normalization technique to pre-process the data. If we divide all the pre-processed data pixels value divided by 255, then all the pixel value comes under 0 to 1, which is used to enhance training smooth and which is to get better results after applying normalization technique. And if you are used for train data and validation data, once the normalization is done, then then it will be stored in NumPy array format. Then store train scale data.npy, train labels, validation scale data, validation labels. Then load using np.load train scale data, train labels, validation scale data, validation labels. Then print here train scale data, validation scale data, train labels, validation labels, shape. This is the dictionary format. Total data is key, which contains a list of train scale data, validation scale data, train labels, and validation labels. Then convert into pd.dataframe, dataframe format. This is the index name, train scale data, train labels, validation scale data, validation labels. This is the column. And then visualize training and validation number of data. Then get number of training images, number of validation images, bar plot training on the testing. Thursday, this is number of train images, number of test images. Train image color is blue and the validation color image is orange. Then dataset number of images, y-axis. Then title is number of images in training and the testing dataset. Totally 5000 images in training set, 1000 images in validation set. Then display here training and the validation set of images using count plot. And they need to convert into PD data frame format, train labels and the validation labels. This is train color red and test color is cyan. Then figure size is 15 and 12. This is a count plot and you need to give class train data, test data, train color, test color, alpha is 0.7, label training set, legend is false. Then title is class distribution in training and testing sets, X label is class and the Y label is count. Then finally plt.show. When you're going to train deep learning algorithm or deep learning model, all the outputs must in numerical format, because of deep learning model can accept only numerical output format and does not allow string or text output format. This is the main reason for converting text or string into numerical format using label binarizer technique. Label binarizer, it is a pre-processing technique which is to convert text into numerical format. Then define it label binarizer. Then fit transform, which is to convert. Then apply into numerical format. Apply for train labels and validation labels. Then output will be T binary multimatrix 1. If the image presents, then it will be 1 here. Then remaining position will be 0, 0, 0, 0. This is the first image. If the last image, then it will be like this. It is the label binarizer output format. Next, we will look at the code execution for the project. First, you need to connect to Google Notebook. Now it is connecting. I needed to open the files and I needed to change the runtime. You need to select the T4 GPU, then click OK and save. First, you need to run this cell to access Google Drive. Now it is connected to the T4 GPU. Connect to Google Drive, then select your account. Continue. Just then continue. Now Google Drive is successfully mounted on the Google Colab notebook. Next, we need to obtain the Kaggle API key. For that, first you need to go to Google, then type in Kaggle. You need to click on the Kaggle logo, then go to settings, scroll down, create a new token and continue. Now it has been successfully downloaded. You need to execute this cell. You need to choose the files. They need to upload Kaggle JSON. Now Kaggle JSON has been successfully uploaded. Refresh it, then execute this cell to create a new folder inside Google Drive. Just execute this cell, then execute the next cell to download the dataset from Kaggle. We need to wait a few seconds for the download. The dataset has been successfully downloaded in zip file format. Then it has been successfully moved into the driver deduction folder. Then execute this cell to unzip the dataset. Now it is unzipping the dataset. Now the dataset has been successfully unzipped. Then execute this cell. Next, visualize the dataset from the training data. Now, the code execution has started successfully. It's running now and displaying images, talking to passenger, reaching, beginning normal driving, texting right. Now simply execute this cell to store the train and validation image paths in the following steps. Within the basic and straightforward dataset loader, the uncomplicated preprocessor as well as the image to array preprocessing step, which is essential, are then execute the htl load function. Now it is pre-processing the images. Then execute this cell for data normalization. Then use Ctrl/ to uncomment. Save the created folder driver destruction reduction to Google Drive. Then run this command using Ctrl+/, then load. Then execute this in total number of images, image width and height. Channel label. Binarism. Training using the resident 50 algorithm. Compilation block. The rest like 1582 cube, comma. Then execute this in then execute the model self-compile form. This is the summary of the model. Initially, the model input shape is 128, 128, 3. After that, it starts decreasing. 128, 134, 134 width and height in the first convolution block, which is reduced down to 64 by 64. And this is filters. The final image width and ID is 2 and 2, and these are the filters size. This is the flattened dimension 8192. This is the first dense connection, which is 512, 256 and 1264. This is the softmax activation function with an output of 10. This is the total number of parameters that are trainable and non-trainable. Then I am going to execute the cell to train the model. Now it has started training successfully, which is running on the backend. Now the model training has been successfully completed and the model achieved 92% validation accuracy with a training accuracy of 93. The loss is 0.22. Validation accuracy is 92%. Validation loss is 0.3213. Next is the classification report, which is used to evaluate the trained model's performance on the validation data. First, we need to load the trained model weights using load weights, then set these weights to the algorithm. Then predict is a function that is used to get the output of the trained model for the validation data. The batch size is 16. These are the class names. Then for the classification report, you need to provide the y-test labels, then get argmax, get only the highest probability value in the predictions, Since these are the target labels, I am going to execute. In the classification report, there are three main metrics. The first is precision, the second is recall, and the third is the phone score. Support is the number of data points in each class. Here, precision refers to the proportion of correctly identified positive cases out of all predicted positive cases. The formula is true positives divided by true positives plus false positives. Here, true positives represent correctly identified positive cases. Then, recall is the proportion of correctly identified positive cases out of all actual positive cases. The formula is true positives divided by true positives plus false negatives. Then finally the phone score, it is an average of precision and recall, generally called the harmonic mean, and the formula is 2 times precision times recall divided by precision plus recall. These are the accuracy score, precision, recall and phone score. For each class, support means the number of data points in each class. Then the confusion matrix, which makes it easy to obtain true positives, false negatives and true negatives. Here the diagonal represents correct predictions while the remaining entries are incorrectly predicted. Classes. Then training and evaluation loss. This is a training and validation loss graph created using ggplot, which is needed to execute the cell. Initially the loss, it was 2.5, then it started decreasing. This is the final last value. This is the training accuracy and the validation accuracy. The accuracy was initially 0.2, then it started increasing with each approach. The final accuracy is 0.92 on 0.93. Let us see how to make inference using trainer model in VS Code platform. First, you need to go where it is that driver distraction monitoring system, then needed to replace with CMD. Then type your code space dot, then it will redirect into VS Code. Now it's opening and successfully opened up driver distraction project folder, and this is the IPMO file. This is the final inference py file. Then input video 1 and input video 2. This is requirements tx file. This is the ResNet 50 algorithm. This is the ResNet 50 model base which will be downloaded from Google Drive, and make sure that it must be exist in the folder of driver distraction project folder. First, you need to import a necessary library for make inference. CV2 NumPy, Tkinter used for implementation of graphical user interface, Pillow which is easy to for image processing and imaging handling, threading and ResNet 50 algorithm implementation. Then sys is a basics Python library which is to handle some basics Python operation. Example sys exit, initially video path is empty. Once the program execution has started, then give video file, then it will be successfully set in the video path variable. Running is initially false. Once the program execution has started, then it will be set as true. Cap which is used to get your frame from video initially is done. Then define a distant 50 algorithm with the input shape and the number of classes. Then set trainer model, weighs it with the ResNet 50 algorithm. Then model files will be successfully loaded. There's the choose file. There is a function which is to get file from folder. Then set video path as global variable. Then access video files once the user is given in the Tkinter window. Then check which is available or not. This is a file label. Select video file. Then show frame, it is a function, all the inference happen in this function. Then access running and the cap using global variable. If not running or cap is none, then return none. Cap, it is a function which is used to access a frame from video. Then frames will be stored. Frame variable rate is either true or false. If frame is available, then it is true. If frame is not available, then false. Then stop the execution. Then define here width and height, which is used to display a frame in Tkinter window with a specific input or size. Then this is the frame. Then this is into the our record format. The model where trainer 128 is width and 128 is height. Then apply normalization. Then endpoint XP dimension, which units batch size. The batch size is here 1. Then predicts function is apply and then feed data to this function, then get output of probability values, then takes maximum probability value from model predicted, then display here text in OpenCV window, font name, font scale, font thickness is 2, text color is red, text is predicted class, driver destruction monitoring. Display here the destruction name, the font name, the font size, the font thickness, and the chosen color. Then convert frame into BG to RGB. Then get a array data. Then convert into image decay to photo image. Then it will be stored into the video label dot image decay. Then configure after rooted, after which is display continuously running in Tkinter window. Start monitoring is initially accessed in the global variable, and then if video path is there, then running is true. Then capture your frame from video, then call show frame function, file label configure. Please select a video file. If it is not select, then stop monitoring. User can stop the execution, then the program execution has stopped. Then define a Tkinter way as root. Then title is a driver destruction monitoring system. This is Tkinter Windows size, which is 1024 and 600, and the window is resizable. Then style configuration, preview heading, and font name is Arial, and font size is 10, and which is bold. This is the notebook configuration. This is the video monitoring tab, and then file frame. This is the button for choosing video file. Then definite video frame, and the title is driver destruction monitoring system. Label for the video, and then the stop button, start button, and then stop button, and then total main loop. Tkinter window is continuously running. Finally, we'll be going to see how to execute the code. First, you need to open terminal, new terminal. First, you need to install TensorFlow, the OpenCV library, and this library, which is the requirements txt. Then type here pip install r requirements txt. Then give enter. Now the TensorFlow and the OpenCV is installing, and now it is successfully installed. Then need to get inference, py file, copy relative path, then cs, then type here py, then inference, py, then give enter. Now the code execution has started successfully. Now Tkinter window is successfully opened. The name we're going to set to full screen of Tkinter window. The window name is driver destruction monitoring system, and then this is the Tkinter log window, which is monitoring name. And I'm going to choose video file, input video 1 mp4, then open, then need to give start. Now the model inference has started successfully. Now it is predicting each frame. Now it is predicting each frame one by one, and driver destruction monitoring safe driving. Now it is processing each frame one by one from video. The frames are continuously updating in Tkinter window. Next, I'm going to give another set of input video. For that, first you need to stop. Now the program is successfully stopped. Need to run again for giving second input video. Pi inference, pi. Now let's begin the inference process. Now the code execution has started successfully. Then I'm going to open Tkinter window, then set full screen, then choose video file, input video 2 mp4, then open, then give start. Now the model inference process has successfully commenced, which is accurately predicted as texting right, and it was indeed predicted with great precision, texting right. Now the frames are continuously updating. Next, I'm going to stop the execution of the program. Now the program has successfully stopped. I hope you got and understand everything in my way explanation of the project on how to execute the code. Suppose if you have any doubts regarding the project or code execution, put your thoughts in the comment section. I'm ready to help you. Thank you.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely help you in as soon as possible in a better way. Thank you.